Okay, so this last page, page 5, the last thing we want to do is to find the distance d between a point and the line. So here's a point Q, which is not on the line, because if point Q is on the line, the problem is simple, the distance is 0. But the point Q is not on the line, and we are looking for the distance. Of course, that means you draw perpendicular to L and then find this, minimum distance between Q and any point on the line L. All right, so here's the idea, very similar to what we did on the previous page. Again, somebody came up with a very clever idea, okay? Because see, the thing is, when you are given equations, the parametric equations of the plane, you're also given a vector inherently. A, B, and C, those are the coefficients for that parameter T is given, right? So you know one vector which is parallel to L, or which belongs to the line L. And so, again, this may be a surprisingly simple way of doing this without any calculus or minimizing function. But in order to find this distance d, okay, now remember you are given the line L and its parametric equations and the point which is not on the line. First, you pick a random point, sounds familiar? Random point P on the line L. And find this vector from P to Q. That's this one here. Okay, and then use a little trigonometry. Now you have two vectors here. You see this vector V and PQ? Okay, you know the angle between them, we can call them theta. Well, actually you don't know this angle, but we can call this theta. Okay, if this is the angle theta, what is D? D is the opposite side of this right triangle. So it is the norm of the norm of PQ, which is the hypotenuse, times what? It's the opposite. It's a sine of theta in this case. Now, the reason we use sine here is because you are given the vector V, which is parallel to line L. Back in the previous page, we used cosine because we were given something normal to the given plane, right? So that's why the difference here, okay? But anyway, so D is the norm of PQ times sine of theta. And of course, we don't know what theta is, so we can't use it this way. But what we can use is the great skill of mathematicians, algebraists, whoever they are, okay? Which is to add something in order to remove something. I mean, that's really cool, right? I mean, it's like completing the square. You add something in order to simplify. And sometimes in order to simplify something, you create a mess, and somehow the mess makes something very elegant, okay? In this case, I can multiply both the top and the bottom by the norm of V, okay? Because that's the other vector we have. And so when that happens, the top becomes, miraculously, what is that? Norm of the first vector times the norm of the second vector times the sine of the angle between them. That is the cross product. Now, you can write this as V cross PQ or PQ cross V. You know these are not equal to each other. One is the opposite. But since we are taking the norm of that cross product, it doesn't matter if you write PQ cross V or V cross PQ. The denominator is simply V, okay? Probably you will have the square root on both of the top and the bottom this time, but that's okay. Very simple. And this will help you find the distance between point, not on the line, and the line. Okay, so let's do one last example here. I think this is the last example. Maybe you can pause this and figure this out. The question is this: find the distance between the point 3, 1, 2, and the line L described by the parametric equations. X is 3t minus 2, y is t, z is negative t plus 1. Okay, so you can tell that this v has to be 3, 1, negative 1. How did I get that? Well, that's, the coefficients here, right? So that's pretty easy to figure out. Okay, so use this method we just did to figure out what the distance is. And you may pause this video for a few seconds. And when you think you get the right answer, you can come back to that. Almost done, okay? So hang on. All right, so what point did you pick for L? Sorry, for P, which is on line L. Um, I think there's a very simple way to do that, which is -2, 0, 1. Where did I get this? It's this, and then of course this is plus 0, and then this is 1. Right? I mean, because the parametric equations not only give you a line or the vector parallel to the line, but also gives you a point on the plane. So let t be equal to 0, you get the point P. Okay, so let's say PQ. I think we can find this easily. Let's just not have this. PQ is what? 3 minus -2 is 5. 1 minus 0 is 1. 2 minus 1 is 1. So 5, 1, 1 is this vector PQ. Again, make sure you know how to find the vector between 2 points. That's one of the easiest things here. And then you take the cross product of PQ and V. Let's say what V is. V is 3, 1, -1, right? Okay, so PV cross Q is equal to, all right, now again, imagine, having I, J, K, if you need to imagine that, but I think at this point you could probably just go like, this and this. -1 minus 1, that's -2. Okay, and then next one is -5 minus 3, that's -8, but remember, the sign has to be changed for the second component. And then the last one will be 5 minus 3, which is 2. Okay, so that's our cross product. And now you can't simplify this. You can't take, you can't divide everything by 2 because I need the norm of this. So the distance is the norm of -2, 8, 2, divided by the norm of the vector V, which is 3, 1, -1. Okay, both will be square roots. That's fine. Okay, so what is that? It's a 2 square plus 8 square plus 2 square. By the way, I can't really help it now, but your homework will have some messy calculations, so feel free to use your calculators. Unfortunately, my open math creates a bunch of these, generates these numbers, which sometimes makes the calculations messy, but that really shouldn't be too much of a problem. I avoided really messy problems. All right, so the numerator will be the square root of 72. Okay, that's 4 plus 64 plus 4. And so that's square root of 72. The top, and the numerator will be 9 plus 1 plus 1, that's 11, right? And so the answer, and of course, oftentimes you can just put one radical, right? And 72 over 11, square root of 72 over 11 is the answer to this question of the distance between the Q, the point, and the line L. All right, so now with these formulas, and I hope you have understood where the formulas come from. And you should be able to recreate the process if you have to. But with a few exercises, you will be able to, use these things pretty well. Now, by the way, I just want to mention one more thing. We are not going to be spending a lot of time finding distance between points and planes and points and lines. Okay, these are the things you need to know before we go on. But if this is not something that you really enjoy, that's okay, because this is really not a major portion of this, this course, okay? The dot product is, the cross product is, and equations of lines and planes, you must know these things. These will come back over and over. If you are not learning them well, they will haunt you for the rest of your semester, okay? But these distance formulas at the end of last few pages of this handout, not so important, okay? But make sure you do your homework to learn these well for now, and focus your energy and focus your concentration on the dot product and the cross product and the equations of points and planes. And so those are the important aspects. Okay, so this is the end of section 2.5. And until next time, have a great day. See you.